Okay, so this question, I want you to do me a favor and make sure you pay attention carefully. Okay, because I feel that I'm getting closer to the end of the proportion theorem. Because I've discussed all the key concepts with these examples. Right, so you're given TV is parallel to WR. Huh? You want to make it large? Okay, let me do that. In fact, that's not the best solution. The best solution is for me to do it the other way. Let me go back here. Let me drop this down. Is that better? Is that better now? Okay. Let me move it a little bit. Okay, so we are given that TV is parallel to WR. That's very important. That means that should be a clue to you that you are supposed to use the proportion theorem somehow in this question. Okay, then you have got PW over WQ. Now, because of this ratio a half, and also the ratio for PV over VR is 2 over 3, I'm going to introduce the concept of the constant. That's the key to getting to the answer. Okay? So if you look at PW, that's PW, it's written here as half, okay, to the half, that is PW over WQ. The WQ is that. Okay? So you've got PW over WQ. Okay? Then, if you look at it carefully, right, this question here, I'm just hoping that it won't require similar. So, if I use the constant, I can call this one here I can call it, say, x from here to there. I can call that one what? X. Yes. Oh. Okay, I can call it x because PW is equal to 1 over PW over WQ is equal to 1 over 2. Based on the concept of the constant, that one there I can multiply it by a constant x. And this 2 I can also multiply it by a constant x. Because the two sides are on the same side of the triangle. Okay? So WQ is going to be 2x. Alright? Then PV over VR is 2 over 3. So it's PV over VR. PV over VR is equal to 2 over 3. So here I can call this one, say, 2y, and that one I can call it 3y. Because it's a different side of a triangle. Okay? You following? Okay. We'll try and catch up. Unfortunately, we've got time constraints. Now, that's the reason why I created the video. So that in a situation like this, you can always go back and catch up. You see the advantage of the video? You see that? Stop laughing because I'm not joking. I'm not joking. Every lesson that I did from Monday, I recorded. She was not in school, she can always be able to catch up. That's an advantage. Okay, if you've got problems with the internet, just bring a USB, I'll give you the videos, then you can watch them over the weekend. I tell you, by Monday, you watch, spend time going over it by Monday, you are going to say, oh, this is what he was talking about. You understand. Okay, so let me carry on. So we've got 2x there, we've got x. On the other side, I've got 2y, 3y. Now, the reason why I'm using two different constants is because we are dealing with two different sides of a triangle. Okay? Then the question 1.1 says if PT is equal to 2x. Now this is a game changer now. Since the question itself is using x, means I have to change this 2x and that x to another what? Letter. Okay? So I'm gonna change this to k. Okay? Because x is already was already used in the question. Okay? You get what I'm saying? What? Yes. So we change this. Okay. Don't allow me. Okay, let me. Okay. But allow me to just cut a fish. Yes. Alright. So that length I'm gonna call it K, and the other one it becomes 2K. I'm changing the constant because it has already been used in the question. So I'll use K there and K. Okay. So we have got 2K there and K. Then on the other side, I've already used Y. So I'll have 2Y and then 3Y. Okay? Then if PT is 2X, it means that from P to T, that's 2X. Let me try to use a different color. So this will be 2X. Okay? Are you following that? Now, check this out. In triangle PWR, okay, we have got two lines that are parallel. That is TV and WR. Therefore, I can use the proportion theorem in that triangle. Okay? And also, I now know that the ratio of PV over VR is 2 over 3. Therefore, the ratio of PT over TW is also 2 over 3. But already PT is 2x, which means TW is going to be equal to what? 3x. So, this is the idea. This line which is parallel, on top of it we have got PV. The coefficient of y here is a 2, which means on the other side the coefficient must also be a 2. Below this line here, TV, here I've got VR, the coefficient of y is a 3, which means for TW the coefficient of x must also be a 3. Yes. So it says determine. Okay, I'm just talking now. I'm gonna write it what? Down now. So I'll say in triangle PWR. I have identified the triangle. That's the first thing. Okay? And I've also put all my what? My lengths in terms of the constants. So if I use the proportion theorem, I'm gonna have PT over TW is gonna be equal to 2y, sorry, not 2y for now, I need to use the proportion theorem. That will be PV over VR. Then I'll write line parallel to one side of a triangle. Okay? You are allowed to label a triangle like that when you write your test or examination. Okay, in your match control, I'll give you a diagram like this. In your answer booklet, you can write things on it. That's the purpose of it. Don't be scared to write on it, please. Okay, so I've written that. Now I'm going to substitute. Okay, make sure you are aware that this reason that I wrote here, this reason, okay, there are two reasons for the theorem. Okay, as I had was in the other lesson before you came, the red group, right? I know that some of you go for private tuition and all the stuff, right? You talk to other learners and stuff. You need to know that the proportion theorem has got two reasons that you can give. Two. Okay? It is your choice to decide which one you like. Okay? I prefer line parallel one side of the triangle. The other one is proportion. You have to write proportion theorem, then you state the lines that are what? Are parallel. The disadvantage with the second one is that if you write proportion theorem and you forget to write the lines that are parallel, your reason becomes incorrect. The first one, the one that I like, you don't have to state the lines that are parallel. So be aware of that. And no one should tell you which one of the two you should use. You must decide. Okay, so I've written that. Then on the next page now, I'm going, since PT is 2x, I need to find TW. The good thing is I know that PV is equal to 2y and VR is equal to 3y. Okay, so I'm going to move on to the next page. So I'll write my PT is 2x. So that's 2x over CW is equal to 2y over 3y. Okay, like that. You might be wondering how is it going to end up solving for y or remove the y. It's very simple. Because of division here, the y and the y will cancel. Okay? The y and the what are going to cancel out. Then we are going to end up having 2x over tw is equal to 2 over 3. I want you to be aware that tw is going to be in terms of x because pt is in terms of x. So you cross multiply there, you get 6x equal to 3tw. Then you divide both sides by 3. So your tw is going to be equal to 2x. Sorry, let me check if I didn't make a mistake. So it's 2x over tw. So that should be my cross multiplication. That's 6x. So that's 2. 2. Okay, so by cross multiplication, that's 6x, that one will be 2tw, then divide both sides by 2. tw equal to 3. Okay, and then you are done. Right? So here I've got my 3x already on the diagram because I've done it what? Mentally. Okay, when I'm showing the working out, then I have to show it until I get the 3. Are you following?
Yeah. Sir, I don't understand. CW is 3x.
You don't understand what it is. The one is in terms of x. Determine TW in terms of x. Huh? Okay. Sorry, can you do me a favor, please? We are talking about this. So be part of the lesson. Because TW times 2 gives you 2TW. And then I divide it by 2 because I want to find TW. Any question? So we are following. Right, let's move on. Let's move on to the next question. Just talk about that. If you pay attention, you won't need to go to the truth. It's feel well. Right, let's go to 1.2. Before I just want to check if I finish there, I finished there. So I'm going to carry on with. It's the same diagram, but because it's geometry, I decided to use it again because of technology, obviously. So just give me a second. Okay. All right. Can I have your attention? Hey, can you stop talking? I said, can I have your attention? All right. Then 1.2 says, then or otherwise calculate the numerical value of QZ over ZB. QZ. Now, what do you think this means? Okay, those two words there. Then and or otherwise. From your English, what does this mean? It means the answer you got in the first part of the question, you need it to answer this one. Okay? So if you get the first question that is TW wrong, you're likely to get this wrong. So let's analyze it. Okay? We already know that this is 2y, that's 3y. This is 2x, and that's 2x. We also, sorry, 3x. But we also know WQ and PW in terms of K. Okay, I might add that later on. For now, this is what we got, right? So the question says QZ. QZ. So it's from here up to there. That's QZ. Right? Over ZB, this is Z, that's B. Okay? You following that? Huh? So check this out. If we want to carry on, which triangle would you use to determine this ratio? To the QVT, because WZ is parallel to TV. The B is here. Okay? Now, in that triangle, for me to get this ratio, I need to know what is the length of TW. I also need to know the length of QW. Okay? Now, I want you to pay attention carefully to what I'm about to do now. It's very, very important. I already know from the previous diagram, this one here, from this ratio, it says PW over WQ, 1 over 2. Then I said QW is 2K and WP is equal to K. Am I right? And also we have got this X here as our TP, which means I need to find the length, this length here, in terms of X for me to carry on. Okay? I need to find it in terms of X because I know that TW is 3X. So I need to find what is the length of QW in terms of X. Okay? Now to do that, for me to be able to do that, I hope you can agree with me that I can write the length of WT in terms of K and the length of TP in terms of K. Okay? So let me go back to the diagram, then I'll show you. So we know that this is 2K, and we know that WP is equal to K, this whole length. So let me use a different color to make it look better. So this is K, and obviously that's 2K. Okay, so if I want to carry on there, in terms of K, WT, if I add 3x and 5 and 2x, I'll get what? 5x. Do you agree with me on that? Yeah? I'll get 5x. So if I want to get WT, I can say 3x over 5x times k, which means the length of WT is like this. WP is equal to k. Okay? In terms of x, WP is equal to 5x. Okay? Because I said 3x plus 2x. But I want to write TW in terms of k. So I'll say 3x. So my TW is going to be 3x over 5x, because that's the total for PW, times k. Okay? The x's will cancel. So it means 3k over 5 will be the length of TW. Okay? So this will be 3k over 5. Right? Fortunately, I know that QW is equal to 2k. So I can find this ratio. But the key is finding the length of TW in terms of K. Or you can find the length of QW in terms of X. Then you can carry on. If you can't do either of those two, then you have a nightmare for the question. Right? So here I'll say in triangle QVP, I can use my proportion theorem. So it will be QZ over ZV is equal to QW over WT or TW. Let me use TW. Okay. Then I write my reason line parallel to one side of triangle. Okay. Now I'm going to substitute now. Okay. Allow me to go to the next page. So I write QZ over ZV. Okay. QZ over ZV. So QZ over ZB is going to be equal to, now check this, QW is equal to 2K. My TW is equal to 3K over 5. So I can write here 2K over 3K over 5. And this will give me 2K over 1 divided by 3K over 5. If I simplify, I'll end up getting 2K over 1 times 5 over 3K. You have to know your fractions. Fortunately, you are in metric. Okay, please. I'm waiting for you to do the rest of what. Are you following? Yeah? Okay. All right. So we have got QZ over ZB is going to be equal to. Now here, this K and that K cancels because that's a multiplication sign. Okay? Then you'll be smiling. and your heartbeat will be normal. So 2 times 5 will give you 10. 1 times 3 will give you 10. And then you are done. Yeah. And I can promise you, if you master what I'm doing here, you never have any problem with the proportion theorem. Okay? You never have any problem. You see a person with proportion theorem, you'll be smiling, knowing what to do, where to start from. Yes. Okay. And this question is not that easy. Not that easy. If you have got a private tutor, I want you to take the question and give it to your tutor. Yes. If you have got one, give them to it. They are going to get the solution. If you got the solution, you just go and give them. And then we'll see. It's not that simple. Right, by the way, just to.
Oh, can you if you don't this one. So
Okay.
one more time, what is it about tomorrow? Investigation? What went
It's on 3.
Yeah, what about it? You said I must know the cosine rule.
Yes.
So I need to know the area.
And all the basics.
And the area, I need to know the area of the triangle.
Okay, just to go on the safe side, just come knowing the area. The area rule we are talking about it now. But it's not very important. The cosine rule is the one that's important.
That's when you're working on like you got 2 sides and 1 end. Alright! Okay. I don't pass it. Oh. I don't know who you are. We shall see you later. I read to you.
Please, you need to remain if you are not writing with the others. Yeah, you have to know your cosine rule, your basic trig ratios and reduction and so on. But no, you don't have to worry about like general solution, graphs and all that. You don't have to worry about it. It's not part of it. No, there is no. You said what? Yeah, of course. Obviously, you don't need the calculator.
I just said if you have the calculator and you know the basics, you know what?
Can you sit down, please, until the bell rings?
Jacob was asking. You want to know if you can bring it along.
Can bring what?
You want to know if you can bring it along.
What notes?
Right?
No, it's not open book. Sorry, Butelez, can you sit down? Okay, I didn't finish all the questions yet. I think I'm left with one. I will talk about the last one. But you try it out. Hey, sorry, Spokers, you need to sit down. Because of COVID, you're not supposed to be too close. Right, everyone, can you please do me a favor? You need to go home and try to do 1.23. Right? Tomorrow we are not gonna have a lesson because of the investigation. So you can take your time and try to do it until Sunday. Then Monday when you come to school, we'll go over that. I'm going to check your answer. By now, you should be able to do that question on your own. Yes, I will send it. Don't worry. Okay. This question requires us to use everything that we had on the diagram, right? So, area of TBQ, that's TBQ, that's the triangle, okay? And then we have got PQR, okay? PQR. So PQR is PQR. Now, to make things easier for myself, let me just label it based on the constants. Okay? Because that is going to help me a lot to carry on. Okay? So this one we called it 2y, that was 3y. And like in terms of x, this is 3x and that's 2x. Right? In terms of k, obviously it's 3 over 5, 3 over 5k, and this was 2k. This is 3 over 5k. Okay. Then, now those two triangles, I'm sure you can see that we have got TQB. This is TQB. Okay, and we have got PQR. They share a common vertex, but do they have a common height? Do they have a common height? No. They share a common vertex, but they don't have a common height because their bases are not on the same strata. What that means is, if I try to use our base times height directly as it is, it won't work. If I try to use the area rule, they don't have a common angle. So what that means is, I need to identify a third triangle that shares a height and It shares a height, both of them. Okay? It shares, or I would say it shares a common height with both of them. Okay? So let's look at TQV. TQV. Which triangle, okay, shares a common height with TQV? I'm talking about a triangle that we probably might know some dimension of it. It's what? WQZ. P, PQV. Yes. PQV, yes. Okay. PQV and TQV, they share common height because they have a common vertex here. Therefore, they share a common what? A common height. Once we identify that third triangle, does it also share a common height with the PQR?
Yes.
Yes. Then we are done with the question. So what you do, this is what you do now. I'm going to write it in full for you so that you can understand. So it will be area of triangle TQB over area of triangle PQR is equal to. Now here you have to use a mathematical technique such that when you multiply the areas, you come up with this. So I want you to be aware that this is equivalent to, check this out, it's going to be equivalent to the triangle that we say is common. That is what? PQ what R is going to be equal to the area of triangle, we say PQV all over this denominator, which is the area of triangle PQR times, I'm using my knowledge of fractions, times the area of TQV, area of T of triangle TQV over the area of triangle PQ. It will be PQV. The reason why we do it this way is because, I hope you can agree with me. Just give me a second, I need to recalibrate it. Okay, check this. You agree with me that based on the product that I wrote on the right, this numerator and that denominator are the same. So they cancel out in one way. Okay? But for our question, we cannot cancel them out. We need their dimensions for us to carry on. So, how would you find the area of PQV? We use the dimensions that we know. Alright, I need you to be aware that for the length of Q, for QV, I can use another letter. So I've got Y, I've got X, I've got K. Let's use M. So this will be 2M. Okay, let me recalibrate. So I'll say this is 2M. Okay? It's 2M because in triangle QTV, if I use the proportion theorem, because the coefficient of the K is 2, the coefficient of that M must be 2. The coefficient of the TW then in terms of K, okay, in terms of K is 3K over 5. So here it has to be 3M. over 5. Okay? The coefficient of the constant must be the same. But the constant is a letter. So, let me substitute now in terms of the constant. The area of PQV is going to be in terms of K. Okay? Remember, it's going to be in terms of what? Of K. It's going to be half. Okay? Remember, it shares the common height with triangle PQR. Do you agree with me on that? They share a common height. So the ratio of their areas will be equal to the ratio of their bases. Right? So in actual fact, I don't need the constant. All I need is that the base of PQV is going to be equal to 2y. So I put 2y here. The base of PR is going to be 2y plus 3y, which is what? 5y. If I wrote, that's 4. But before I carry on, I want someone to ask questions. I want someone to ask before I carry on why I wrote 2y over 5y. It's because these two triangles, they share a common vertex, which is this one. Okay? They share a common vertex. Remember, we have got P, Q, V, and P, Q, R. I think we did probably. Yeah, we did. Right? But let me write it this way. Times the area of TQV over area of PQV. Remember, TQV and PQV, they also share a common what? Common height. Therefore, the ratio of their areas will equal the ratio of their bases. Make sure you know that. I think I told you that the other day. That if two triangles share a common vertex, if their bases are on the same straight line, it means that the ratio of their areas will be equal to the ratio of their bases. I spoke about maybe on day 1, day 2, somewhere there, but I spoke about this. Okay? So, the area of TQV, remember, if T, can you do me a favor and look here? TQV, okay? TQV. And then we also have PQV, that's PQV. They share a common vertex. Which one is the vertex that they share, which we can consider? It will be this one here, not that one. Okay? Because we want them to have a common height. So we choose this vertex here. You follow what I'm saying? Yes. So if we choose this vertex here, means those two triangles are going to share a common height, and that height is going to look like this. They are not right angled triangles, so it will be, you can draw it like that. That will be the common height, this length here. Okay? Then, once I have that, then the base of those two triangles for PQ for TQV, that is TQV, its base will be what? I expect you to look here. Because the diagram is not on TQ. It will be TQ. Thank you. You see that? Okay, let me warn you. If you miss that, this question here, you'll never be able to understand what's going on. Okay? The two triangles share a common vertex. Okay? And their bases are on the same straight line. Therefore, the ratio of their areas will equal the ratio of their bases. But if I ask you to draw or construct where the height is, this will be the height. I hope you are aware that if I give you a triangle like this, and I ask you to say, construct the height you construct it outside the triangle. Like that. That's what I do. And the height is always perpendicular to the base. So This height is perpendicular to PQ, therefore it's also perpendicular to TQ. So thank you, Taomo. So it will be TQ. But our TQ now, we need to write it in terms of K, because QW is 2K, TW is 3X, it's also equal to 3K over 5. So I have to add 3K over 5 and that 2K. So I can write that as 2, it will be 2 plus 3K over 5, so it will be 2 and 3K, so it's 3 over 5K, like this. I can simplify this and write as 13 over 5K. Just help me, I'm going to do that. So it will be 13 over 5K divided by the area of PQV, okay, is now PQV now. It will be the length of P what? PK. Do you agree with me that the base? Do you agree with me? It will be what? PQ, which is equal to K plus 2K, which is what? 3K. So I'll put here 3K. Then start smiling. The K and the K cancel. Y and the Y cancel. Okay? Then you are left with fractions. So 2 times 13 over 5 will give me 26 over 5. So on the next page, I'm going to write this is equal to 26 over 5. That's all over 5 times 3, which is 15. Then I'll remove the division line, introduce the division sign, so it will be 26 over 5 divided by 15 over 1, and that will be equal to 26 over 5 times 1 over 15. Okay, so the final answer will be 26 over 75. Okay, yeah, it's a level 4 question, by the way. So TQ over PQ1. Okay? It's a level 4 question. Okay.